We are here on question 75, which is a vocabulary term. That vocabulary term is wave. So what is a wave? A wave is a pattern that describes how energy is carried from one place to another. So pause this video and copy the definition down. All right, next we have a demonstration using a slinky. If you were not here, we went out into the hall. I've got a quick video of this activity. We learned just now that waves are patterns that carry energy from one location to another. So I'm going to apply a little bit of energy to this, and we're going to watch a wave carry that energy. So here we go. And it carries it back and forth. You see that change being moved back and forth? That is, okay?
How much was that?
That is energy being carried by a wave. All right, quiet please. We learned that waves have two properties just now: wavelength and amplitude. Amplitude is how much the wave gets moved off from where it currently is. And amplitude measures the amount of energy put into the wave in the first place. So here, I'm going to do a small amount of energy. Not a very big change, right? We didn't see a very big wave there because it didn't have a whole lot of energy. Low amplitude, low energy. Now I'm going to apply much more energy to this. And you see we have a much larger amplitude. More energy means a taller wave with higher amplitude. Large amplitude.
It's still going.
Yeah. So, amplitude for waves measures the amount of energy. The other term we just learned about is called wavelength. Wavelength determines the type of wave that it is, or the properties of the wave. So we can have a long wavelength where there's big gaps in between the peaks. So what's your name down there?
Graham.
Graham? Okay, so between Graham and I right now, there's only one or two places where there's a peak for a wave. This is a pretty long wavelength. That would be like a radio wave with light. Now we're going to do a much shorter wavelength where we have a whole bunch of peaks in between us. This is a much shorter wavelength. So, long wavelength, just one or two waves in between us. Short wavelength, lots of waves. So, amplitude measures energy, lots of energy. Wavelength determine the type or property of the wave, so the type of light or the type of sound. So we're going to do four things. First of all, a long wavelength with a low amplitude. This would be like a weak radio wave. It's barely moving at all, right? Not very much, not super exciting. Here, we're going to do a long wavelength with a large amplitude. So this would be like a powerful radio wave. Much more energy. Now, we're going to do a short wavelength, low amplitude, not a lot of energy. So there's a lot of waves, but they don't move very much back and forth. And the last one, low wavelength, high amplitude.
Where are my friends? Where are my friends in college?
Okay, the last thing we're going to do has nothing to do with waves. It's just cool. We're going to let go at the same time. I'm going to say 3, 2, 1, go. When I say go, we both let go, okay? 3, 2, 1, go.
Whoa, what?
That was pretty cool. I think
All right, so that was the slinky demo. Next, we have a vocab term, light. Light is a type of wave that carries energy from one place to another, even through empty space. So we've had this word before in the last chapter, and I said it was not a very good definition. Here, we go in a little more depth, and we've revised the definition and added to it. So write this new definition down for light.